There we go. Oh, well, welcome people who aren't here. Enjoy listening to the interruption. So I'm going to try and talk over this. A particle starts at x equals 0 and moves along the x-axis with velocity v of t equals t squared for time t greater than equal to 0. Where is the particle at t equals 3? So the area, so let's find our Riemann sum, and then we're going to talk about what our Riemann sum is actually giving us here. So this one has a real-world context. All right, so we're starting off at 0, and here we're going to use a midpoint Riemann sum, and this one's in your notes. Oh my gosh, my cord is tangled. Midpoint Riemann sum and 12 subintervals. Right, so we go from our change in x is 3 minus 0 divided by 12, so that's going to be 1/4. Oops. And our graph is already labeled like that. All right, so we're using a midpoint Riemann sum. So if we were using a left, we'd start at 0. If we were using a right, we'd start at 1/4 here. But for a midpoint, we're going to start at the middle value. So we're going to use 1/8. Right? And then each time, we're going to go up by 1/4, right? Because that's our change in x. There we go. Right? So this one here is at 1/8. If we add 1/4 to that, that'd be 3/8, right? So this value here is 3/8. So it's just going to be the halfway point. So, oh, I see. Sorry, this line over here. Did I draw an extra line? 1, 2. Yeah, I needed one right there. So there we're at 1. So here we're going to, this would be 1/4. We're not going to use 1/4. We're going to use, and we're not going to use 0. We're going to use this value in here, 1/8. And then the next value would be 3/8, because that's 1/4 plus an 8. Or 1/8 plus a 4th. And then the next value would be in between here, and that would be 5/8, right? Because that would be 3/8 plus one more 4th would be 5/8. So notice each time it's in between the right and the left, right? Because the right would have used 0 and then 1/4, and then, or the left would have used 0 and then 1/4 and then 1/2. The middle is going to, and the right would have used 1/4 and then 1/2, but the middle is going to use the halfway point. So 3/8 and 5/8 and so forth. And 1/8. All right, so each time we're just going to go up by a 4th here. All right, so we won't use 6/8, which is 3/4, but we'll use that middle value, which is 7/8. And then the next one would be 9/8. And then 11/8. So once you get the hang of it, you realize you're just counting up by, by 1/4 each time, by 2/8. So this one's 15/8, and 17/8, and 19/8, and 21/8, and 23/8. Does that make sense to everybody? Okay. So that's the values so far, just the values. So now, fortunately, we have an equation. We don't have to try to approximate it on this graph here. So we're going to need to know the following. And the class who's here will help me out with this. So we have f of 1/8, f of 3/8, f of 5/8, f of 7/8, f of 9/8, f of 11/8, f of 13/8, f of 15/8, f of 17/8, and f of 19/8, and almost f of 21/8, and f of 23/8. All right, so now we need all of those values. All right, so, and they're all just squaring them. All right, so actually, I will only need help with a couple of them. So this will be 1 over 64 and 9 over 64 and 25 over 64 and 49 over 64 and 81 over 64 and 121 over 64 and 169 over 64 and 225 over 64 and 289 over 64 and 381 over 64 and 441 over 64, but I don't know 23 off the top of my head.
How did you know?
How did you know 3 before 21?
529.
529. 64. All right, so those are our values. So our area is going to be the change in the x times the sum of all of those values that we have there. All right, so now we need to add those up. All right, so fortunately, they all have the same denominator. So our area is going to be 1/4 plus, then times 1/64 plus 9/64 plus 25/64 plus 49/64 plus 81/64 plus 121. Start putting these in your calculator, Tristan. 64s plus 169, 64s. I don't know how it's starting to become 24. Plus, what did I leave off? 225/64 plus, we need more space. 289/64 plus 381/64 plus 441/64 plus 529/64. Is that times 1/4?
Oh,
So we're going to get the total answer here.
145 over 16.
145, wait,
Yeah.
145 over 16?
Yeah.
Okay. That's nice. The calculator reduced for us. Yeah. So the reduced answer is 145 over 16.
It would be 2,320 over 64.
Everyone hear him? 2,320 over 64, and that reduced to 145 over 16. All right, so now what does that mean in terms of this problem? All right, so this is the velocity curve. The area under the velocity curve describes position. So if the area under the velocity curve is 145/16, so let's look at our units here. T is 3, so let's say T is in seconds. And maybe our V here, we're talking about, so maybe V of T is in meters per second. All right, so this is meters per second. All right, so our velocity is in meters per second. Our position would be in meters. So if we have an area of 145 over 16, that means that the change in velocity is 145/16 meters. And that was with a time period of 3 seconds. So when you find the area under a curve, under the velocity curve, it tells you about position. So now we know the change in position. Right? If we know our starting value, if we know where we're starting at, say we know that we're starting at the origin, then we would actually be able to find the exact position. Right? Here we know the change in position because we're not given the starting value. Questions on this? So this is a big idea. So it does have a purpose. And it gives us information about our function, about when we integrate the original function. In this case, the position. So area under the velocity curve gives you information about position. Area under the acceleration curve would give you information about velocity. It would give you total change in velocity. So this is our change in position.
It's like you doing derivative backwards.
Yes, it is, in a way. We'll connect the ideas later, but you should know this much so far. And then this was in your notes. Did I leave it all written in, or did I have you do
I
fill-ins?
didn't even see it in.
Yeah, I tried to look for it.
I don't think it's in the notes at all.
I didn't put it in the notes.
I don't think so.
That was what went in the missing spot. So now I know what went in the missing spot.
It was missing.
It was this. So I will give you a copy of this. I will print this out for you.
Save like 0.2 megabytes on my phone.
Yeah, I will print this out for you. All right, so let's look at the next one. Oh, we're running out of time.
How'd you get it? Okay. Only took like 15 minutes.
All right, so this is the, I have it again. So let's see if I forgot to say anything in here. Why do I have a different, I have the same value over here. I just didn't, we had a different number of reducing.
Yeah, it didn't reduce this one.
Oh, that's odd.
That value.
I say 23. Oh, you're missing. That's 2300, not 2320.
Oh, that's why I'm missing a 20.
Yeah.
We lost a 20 there. All right, so let's-
64 is in the bottom instead of 16, which would be accurate.
Yeah. I don't think there's, so
16.
the only thing I'll add to your notes is just the information here about the left starting at the beginning value, F naught, start at 0. The right would start at F naught plus the change in X at 1/4, and the midpoint starts halfway between the two. 0 plus 1/4 or 1/8, and then we'd count up by those. Right. So obviously this answer is wrong because that answer is missing a 20. But it has a right idea. So how far the change in position, how far the particle traveled. And I drew the nice bar, and I kind of drew out the bars on that one. I didn't draw the bars on this one. I'll give you the one with the bars drawn. I'll draw the bars into. Right. Any questions on this one? So I'll draw in the bars. Actually, I'll use the one with the bars already drawn in. I'll just fix that number.
I see what happened. Look, 361 over 64. That's supposed to be 381.
Oh,
That's where this one was missing.
unless I wrote down the wrong number.
You wrote down the wrong
Wrong number this
Yeah,
time.
Yeah.
Did I get 19 squared wrong?
Let's see.
Is it 381 or 361?
Oh, it is 361.
Oh, it's 361. Oh, so this one is right.
Yeah.
So this one is right.
Yes, the other one, it's not 380.
That's okay. So this is the one I will print out for you.
I mean,
I gotta do the closing. So I better stop.
No. That's okay, the computer stops working.
Yeah. So we'll look at a review of Riemann sums tomorrow, and then we're going to look at tables. I actually had hoped to start the trapezoid rule, so obviously I'll be doing trapezoid rule over the weekend. Man, time goes by way too fast. So here,
Our test is the first week of May.
yeah, no, the practice test is May 5th. And then I will post a link so that you can register for that, and you need to register for that. Where's my closing?
Let's see, it's Tuesday, May 15th.
oh, it's the 15th. It's the day before we leave.
That gives us more time, though.
Well, according to college, so it may be different here.
Yeah.
No, it has to be the same.
The same.
Oh, okay, so yeah.
Has to be the same. Oh, I'm going to stop recording. So people at home, I'm stopping recording.
So